Hello, friends. Welcome to Science Talk. I'm your host and resident oceanographer, Jim Massa. In an article that appeared on the online publication EOS, that was dated 27th of June of 2022, we have a very interesting little story to share here. Algal mats may be a key to the Arctic food web. Melt ponds and sea ice have thriving algal communities with startling high levels of photosynthetic activity, translating to high levels of primary productivity. So here's a photo of scientists collecting samples from algal mats. Uh, and this is sea ice, kind of jumbled up here. It's sea ice. I the skiff is not shown here in the photo, but I hope it's not too far away. You don't want to be taking a dip in those waters. Now, without a Gumby suit, let's put it that way. The underside of sea ice in the Arctic is covered with a biofilm of microorganisms and algae. As sea ice melts during the summer, it can sometimes form melt ponds on its surface. And as a result of that, some of the algae may find their way in there and then they start forming these little mats. Now, I did a video some time ago about ice algae. You may want to check that out because it ties in very nicely with this. I'll touch upon some of those points I made in that video later on here. A recent study published in Frontiers in Marine Science showed that these mats have very high photosynthetic activity, suggesting that they might be an important underexplored element of the Arctic food web and therefore underappreciated. So this is like new development basically. So how can microscopic algae support everything from ciliates to cod to the know Arctic's largest terrestrial predator, the white bear? Right? Well, polar bears are there because there's food for them somehow. And the lead author was Casper Hankey, who's a researcher at the Norwegian Institute for Water Research. What they eat also needs to eat something and needs to eat something, etc., etc., i.e., the food chain. Researchers have known about ice algae for a long time. Legendary Norwegian explorer Fridtjof Nansen bottles are named after him, which is a sampling device, described them during his historic 1893 expedition, in which he intentionally froze his ship in the Arctic sea ice, trying to reach the North Pole. Didn't happen, but he was able to map out the surface currents in the Arctic Ocean, which gave us uh, a first understanding of the flow in the Arctic Ocean. However, over the next century, ice algae kind of got ignored. In '04, Hanke was studying carbon flows in the Barents Sea as part of his PhD research when he encountered some of these small mats floating in the sea ice melt pond. So he did some measurements, presented them because he was surprised at the findings, presented them to his basically PhD committee, and they poo-pooed him. Yeah. They said, you don't really, that's nothing there. No, no, no. So, over the next couple of decades, there has been increased research on ice algae. And so Hankey finally decided, I'm just going to publish what I got here. But what's really interesting is he showed very high rates of photosynthetic activity in the mats, and it showed very high, and of course, you're going to have high photosynthetic activity, you're going to have high productivity. And the activity is important because the carbon the algae produce feed the next level of the food chain. In this case, tiny grazers called ciliates. Well, ciliates, the grazers, are then eaten by amphipods. Amphipods are a food source for polar cod. Seals like to eat polar cod and other fish, but they like to eat polar cod. And then the polar bears hunt the seals. There's your food chain. Look how many levels, right? Producer, ciliates, amphipods, fish, mammal, bigger mammal. Quite a few layers there. And this, I guess, photo showing a little experimental setup. There's a bit of the algae there, the mat, and they're measuring in this particular the oxygen profile of the algal mats, like presumably what they're producing. The study added a new aspect to this environment that Philip Asme, a researcher at the Norwegian Polar Institute, he wasn't involved, but he did find similar algal aggregates, uh, in 2012 when he was on a research cruise in the eastern and central Arctic. In his study, Hankey used oxygen microelectrodes, which is an innovative technique for ice algal mats. With these microelectrodes, they were able to measure primary production on very fine scales inside the aggregates. And Asme's research, he was not able to do that. But be that as it may, that gives you good, accurate results, fine. But here's the problem. The ice is warming at a rate 2 to 4 times faster than the global average. It's definitely three, possibly closer to the four. And of course, we all know the ice is thinning. We all know it's disappearing. And now the melt ponds currently cover as much as 60% of the sea ice area during the summer months. So now you're doing what? You have liquid water. The liquid water gets heated up because it's already in the liquid phase. It's going to be absorbing sensible heat, which doesn't require as much to melt the underlying ice. So, yes, you need latent heat to change the ice into liquid, but you already have water covering. So, the absorption and then the transfer will increase the rate of melting of the ice that the melt ponds sit on top. So, there's clear evidence there's more and more melt ponds, which means the habitat for these ice algal mats might be increasing. And it could be more important in future global warming, until a point when the ice melts and disappears totally. Now, one may think more melt ponds might mean more floating algal mats, but we know, as I just said, we're heading towards blue ocean events. But if even if without a BOE, uh, the summer ice extent is declining quite dramatically. So we're going to lose that potential. So the recruitment of the algae could become compromised. In the winter, the algae sometimes freezes into the ice, repopulates the ponds during melting in the summer. If there's no ice present, then the mats lose their buoyancy and they sink to depth and they kind of don't return one way. Because of the role in the food web, learning more about ice algae deciphering their fate on a warming planet is important for the entire Arctic ecosystem. Okay, now, as I said earlier, I did a video on ice algae, and I showed in that video, I showed plenty of photos from the underside of the ice. We've seen plenty of the algae there. And at the time, I stated that that was an important uh, uh, aspect for productivity, for total productivity in the entire Arctic ecosystem. So I was saying this for some time. I also described that when the sea ice melts, that it does during the summertime, you have the melting ice creates a little stratification where you get a little stability, and you then create what's called ice edge productivity. Well, the ice edge productivity is important because, well, it's productivity, adding to the overall total primary productivity for the entire Arctic region. Because when that starts happening, the sun is still not yet high enough to activate the electron train transport system in the phytoplankton. So until the sun gets to a sufficiently high angle to activate the ETC, uh, or electron train transport, okay, system, basically goes on inside the chloroplast. Until the sun energy gets high enough to activate that in the diatom, you're not going to get the productivity from the open water phytoplankton. So with sea ice, you really have three sources of productivity that contribute so that you get your amphipods, your cod, your seals, and your polar bears. You have the ice algae on the underside of the ice, which is where they commonly form. You have ice edge productivity, then you have the open water. Well, here they're now identifying, that sometimes you get these mats because you get some little meltwater pond on the surface. So for whatever reason, it doesn't flow and start mixing and stratifying with the ocean, but might be the shape of the ice, what have you. So some of that water gets trapped, and then maybe the algae was frozen in the ice, and then the ice melted, and then the algae can now, it's in the liquid water, it can now form the algal mats. But this is now being demonstrated to be an important productivity uh, contribution. But the overall point to take away from this is that as we lose the ice, we're going to lose three of the four mechanisms that contribute to primary productivity. So in the past, I said you had three main things. You have ice edge, the algae on the underside of the ice, and then the open water productivity. Well, looks like we now have identified a fourth, and that is the melt ponds with the algal mats on top of the ice. Well, if you lose the ice, you're going to lose the algal mats and the melt ponds on top of the ice. You're going to lose the productivity from the underside of the ice, and you're going to lose the ice edge productivity. And all you're going to be left with is the primary productivity of the open ocean phytoplanktons. Overall, there should be a significant reduction in primary productivity. Now, there is some, to be fair, I've seen some recent studies that seem to indicate that there might be some other mechanisms that might help boost the primary productivity of the open water diatoms, namely some of the slightly warmer temperatures, but more importantly, there's been an increase of nutrients being brought in. So now the question is, how does this interact with the sunlight energy requirement? But there are some studies that seem to indicate, with the increased flow coming in from the Pacific side, most notably, seems to where this increase in productivity is being observed, that could be a possible mechanism. So there could be some offsetting mechanisms, but when you look at this overall, when you lose the ice, you lose the extent of the ice, you lose the how many months of the year the ice is present, we are losing a substantial contribution to the overall net primary productivity. So this is interesting, but it's also alarming knowing what's happening to sea ice. There you have it. I wanted to share this with you. We'll talk soon.